AI infrastructure conversations tend to be dominated by GPUs, data center buildouts, and power and water consumption, but networks also play a crucial role, whether you're supporting huge file transfers to a compute cluster, streaming telemetry from edge locations to feed AI pipelines, or providing high speed, low latency connectivity for AI agents. On today's Tech Bites, we talk with sponsor Equinix about why the network might be the most underestimated piece of your AI strategy and how to think beyond traditional cloud or on prem deployments to unlock new possibilities. I'm Drew Conry Murray with my co host Ethan Banks. Our guest is Kevin Egan, Senior Director, Strategic Initiatives Group at Equinix. So, Kevin, welcome to the podcast. And I'm sure most of our listeners are familiar with Equinix, but for those who aren't, can you give us the nickel tour?
Yeah, thanks, Drew. So, Equinix is a global infrastructure company, a data center company. We are in 76 markets in 36 countries, 6 continents. We have almost 300 data centers globally
Mm-hmm.
and are providing, our 10,000 plus customers with the infrastructure needed to do workloads that power everything from AI to mining to networking and service provider, you name it. We're the fabric that runs and enables the world to kind of move forward. So that's a little bit about Equinix. We've got a 99.999% uptime in many of our data centers and are headed towards almost 100% renewable energy coverage in 2030. So we've got a lot of great sustainability goals in front of us, and that's a little bit about Equinix.
Okay, well, that's going to be key. I'm glad to hear about the sustainability, especially given our topic today, AI. So, what's Equinix's view on the AI infrastructure landscape? What kind of trends are you seeing affect the networking side of infrastructure in particular?
Yeah, absolutely. I mean, we're kind of seeing four major trends develop. First, workloads are really being pushed to the edge, and this distribution of workloads is kind of being driven by smaller, more domain-specific language models, right? This versus purpose-built, general, huge language models like OpenAI. We're getting more vertical or a healthcare or a telco or certain specific industry-specific models are getting smarter and smarter. And so this smaller language model with more specific data is really built to support those edge workloads as they're coming in for certain inferencing type workloads like robotics or manufacturing or automotive, self-driving. All of those things are kind of being framed with these smaller language models. The other thing that's happening is really agentic workflows. Agentic AI is taking advantage of not only these smaller models, not only these edge use cases like inferencing, but also the new technology. MCP is kind of the new API.
Mm-hmm.
MCP plus frameworks and blueprints. If you look at NVIDIA, they talk a lot about their framework, their software. They really want to be a platform player, not a hardware specific, vendor. And so that is really kind of driving a lot of creativity and a lot of distribution of AI versus the AI factory mindset, which is still pretty prevalent for those workloads that need the high horsepower centralized location.
You're saying
But
MCP means that jobs and workloads and data and workflows could be running anywhere.
Well, MCP means that those workloads are able to be more flexible. So with that type of framework, it allows you to choose different models based on the use cases more seamlessly.
Mm-hmm.
So think of it like instead of that API type technology, using your agents with an MCP server, for example, you can then access different models, test different models, get different results with different models. And we see this with all the blueprints. Everybody's coming out with blueprints. Those blueprints, like NVIDIA blueprints, or I could name half a dozen vendors, including GSIs, who all have their own blueprints. But these blueprints really allow that flexibility to say, okay, Drew, your business really needs to take advantage of this smaller language model. We're going to use today. We're going to try it with Google Gemini. Tomorrow with an OpenAI. Tomorrow with a Lambda. Tomorrow with and we're going to get the best results for the most cost-effective results and the fastest results too. Because if you're getting an 100 billion parameter model, it's not going to be very speedy, for example. So yeah, so that architecture, that MCPs and the blueprints being driven by that distributed type of architecture is really allowing flexibility, is what I would say.
So we talked about workloads moving to the edge, the rise of small language models, agentic AI, and MCP. What is the fourth major trend that you're seeing?
Yeah, so really it's the kind of the rise of neo clouds and the rise of what we call sort of AI service providers. So obviously the clouds have an easy button set of services for a lot of, really in particular generative AI use cases.
Hmm.
But, like an AWS Bedrock and these, they've got pre-built use cases for those customers. But with the rise of neo clouds and GPU as a service, really being able to provide more scale to more customers, especially as the GPU scarcities and sort of who's got power, who can allocate and do those type of things. Being able to turn those on and off, like we always heard in private cloud, right? You want that cloud-like experience to be able to try, only consume, only pay for what you consume, right?
Hmm.
So now it's a similar thing happening with GPU as a service, and the neo clouds kind of providing that AI that you consume, and in this case, GPUs. So we're seeing a lot of those specialized AI service providers, we'll call them, and that list is growing, and they have some pretty specific needs that kind of tie into the big picture as well.
Well, Kevin, how do you guys fit into that? Because you're not a hyperscaler, Equinix is not a neocloud, et cetera. So, how do you fit into this picture?
Yeah, it's a great question. Thanks, Ethan. It's like, what we've been talking about with our analysts is, hey, we're the third option. Not only could you do this on-prem, could you potentially do this at the edge, but you could do this in the cloud and choose your cloud service provider. We're the third option, which would be that co-location. And what makes us unique is that we kind of sit between your on-prem or edge and the clouds. We have that interconnected fabric so we can directly connect you to those cloud service providers, to those network service providers, and now to the AI service providers and the neo clouds. So we've got a layer two fabric. We call it Equinix Fabric. It's a software defined fabric, and it really allows you to kind of do that direct, private, secure, very high speed access to your other set of providers, cloud, network, and AI providers.
That is,
And
you're the transport that interconnects me to all of the different wherever it is that I might be running my AI workloads. You can get me there the most quickly with the lowest latency and so on.
Yeah, it's set up for this AI world, right, Ethan, where high speed, low latency, and secure connections to those providers really can mean faster results, better customer experience, all of those things, and allow that massive transport of data between those different locations, whether it's transporting between cloud and your private data set or edge locations and your private data set. Yep.
what are you seeing with this edge use case and how it's tied into this notion of distributed AI infrastructure?
Yeah, so what's really cool is the edge is getting more and more powerful based on, some of those trends we talked about earlier. And with the edge getting more powerful, that really it's a data issue. Data, it means more data is being utilized at the edge, being crunched at the edge, being, for AI and inferencing type of workloads, that's happening at the edge. And that requires a very different type of workload, right? So your east west versus north south really comes into play and having that low latency. So here's an example, right, Drew? If I draw a line from say, our DC data center, from Canada all the way to Miami, we can get you sub 10 millisecond latencies in that entire eastern geo. Same thing from a Santa Clara data center, right? North all the way to south, we get
Mm.
that. So what's happening is we're calling a metro edge. We have customers who are taking advantage, collecting data at those edges. If you think of like almost an SD-WAN type of topology, they can now have very, very powerful, very have the ability to move massive amounts of data in and out of the edge. And you don't necessarily have this one core location where everything has to spawn from. You actually have very powerful metro locations all over the globe. And so for customers, especially that have a golden triangle, you've got London, you've got Dallas, you've got Tokyo. Now you can actually have that directly connected and move data around the world as well.
So that's the transport side. Are folks also thinking about co-location in terms of I need some compute resources in specific locations?
Yeah, absolutely. I mean, we've got a customer right now that, for example, they've got a core super pod running many GPUs, crunching massive model training, and they have that inside of Equinix because they want that privacy, that intellectual privacy protection of their model. They don't want to share that model with the cloud, for example. But then they also have edge inferencing, smaller like H100 clusters at the edge, so that they're closer to where they're collecting those data sets in those regions that they can run inferencing workloads at the edge. And they're able to move that data back and forth from their core to the edge, for example. So
But it's not just performance, and it's not just keeping your data set out of the big cloud providers. It's that what you just told me. I heard data governance. So if I got compliance issues and concerns, I can meet those concerns.
100%, Ethan. Our prime, we say privacy, but really what privacy means is regulated industry, first and foremost. It means model protect or intellectual property protection, like that customer example I shared. And then it also means locality, residency, sovereignty. So you have customer data in Canada, for example, it has to remain in Canada, due to those compliance things. Absolutely, you need a global strategy. And so those are the type of enterprise customers that really take advantage of that co-location. Yep.
Okay, well, okay, you said enterprise customers. Give me an example of the kind of organizations that should be thinking about colo as part of their strategy, rather than basically outsourcing everything.
Yeah, so it's two primary customers. Well, it's more than two, but it's large enterprise that have that global footprint, right? The golden triangle we talked about. They've got data that sits all over the globe. They have major offices in those locations, and they need to move that data and connect that data to securely. The other would be the providers themselves. They're our biggest customers, right? So network service providers, they get the reverse effect by having that high-speed direct private access to enterprise customers. And so we have sort of a magnet model when it comes to NSPs and CSPs. If I want to move that data in and out securely from cloud or from network providers, and now AI providers like neoclouds, that magnet strategy is also there.
That is, a neocloud is interested in peering with Equinix because a lot of their customers are going to be paired with Equinix too. So it makes sense. They're now close to where that data is that they want to ingest and process.
Absolutely, that's right. Yeah, and it's more than just neoclouds because there's a whole class of AI service providers that are beyond just SaaS providers, right? SaaS providers, they run in and out of the cloud, and obviously we all take advantage of those every day, the SaaS clouds. Neoclouds primarily means GPU as a service, but then there's new classes of AI service providers who are also providing different services that need that high speed and private connection as well, so they can do things much more quickly, including hardware.
So I feel like our modern networks seem pretty robust. They're delivering voice and video traffic pretty reliably. We saw through the pandemic that, even with folks being all over the place, working from home and so on, the network did pretty well. And of course, traditional business apps and e-commerce are still going on. So are we kind of like in good shape to support AI-driven traffic, or is AI going to introduce new considerations for network engineers that they should be thinking about?
Yeah, there are a lot of studies, Drew, that sort of indicate, okay, if we're close to 50-50 today on data being created by inferencing and model training and tuning, a lot of the projections say that in the next several years, it's going to be 2 to 1, right? Inferencing type workloads, meaning edge workloads, are going to be creating the majority of data. And a lot of the projections say up to 75% of new data being created will come from the edge. And we've been building towards this, right, Drew, with Internet of Things and all the, every smart thing on the planet consuming. Well, now those smart things are like, GPU laden workstations. But you know what I'm saying? I think that absolutely the network has to be able to transport massive amounts of data to and from the edge, and do it securely and do it with very high bandwidth and very low latency. So I think it is evolving the network demands as those use cases continue. And I think agentic and the MCP, the rise of MCP and this ability to switch models quickly and take advantage of smaller models, they're still pretty sizable, right? They still have lots of parameters in order to get the good results. So that data has to be moved around. And so, yeah, I think our networks, while robust, are going to be able to take advantage of new classification of AI driven innovation.
Hmm. You mentioned fabric intelligence at the start of the conversation. Can you give us a little bit of background on what that is and what folks should expect Equinix is providing with that?
Yeah, absolutely. So we rolled out Fabric Intelligence at our AI Summit a few weeks back. And really what this is the concept of making that, in our case, the Equinix fabric easier to interact with, more intelligent. It starts with observability and network observability and being able to integrate both directions into your Splunks and your Datadogs and into your Google Cloud monitors and all of your type of tool sets for full stack
Hmm.
observability. But then it's also creating that agentic networking assistant where I can ask it, hey, what's the best route to connect between Dallas and London 6, right? And it comes back natural language input, uses that agentic workflow, uses things like generative AI and vector database to kind of come back with, you know, recommendation to say, hey, the best way is for you to use Fabric Edge, for you to connect it in this way. This will give you this specific latency between those two connection points, and that's what we're rolling out with our Fabric Intelligence. And so, really, kind of interacting with your Fabric, making it easier, making it seamless, making it frictionless, so that you can create that experience and really be able to modify that to your workload rather than the other way around.
So what I'm hearing is one, there's like a software-defined element or an automated element to make the fabric easier to consume, and there's also, it sounds like you're building an AI front end, an LLM-driven natural language interface for folks to interact with.
Absolutely. And we're actually integrating MCP into the fabric itself. And so we're able to offer those and really kind of support that agentic workflow and the different blueprints that we spoke about earlier, be able to implement those to do any manner of things. But absolutely, the fabric intelligence is using that a whole collection of those tools to really interact seamlessly with your fabric and be able to kind of get the best routing and the best connection as fabric becomes more and more part. It's already software defined, Drew, right?
Mhm.
So it's already kind of a layer two software defined fabric that connects securely to clouds, to service providers, etc. And now we're just making it easier to interact with that and really more intelligent all the way across the board and easier to integrate with your favorite full stack observability tools as well.
Well, Kevin, we're out of time. If we've piqued folks' interest in this, where can they get more information about what Equinix is doing for AI infrastructure?
Yeah, absolutely. Go to Equinix.com, look at our distributed AI pages, and we also have a number of blogs that are written around the subject too that I encourage you to go and view as well.
We'll have a bunch of show notes in the link that accompanies this podcast when it comes out. There's all kinds of resources for you, including a solution brief, a deck, and some interesting data from IDC on just how insane this AI build out is going. So make sure to check that out. Thank you, Kevin, for being with us. And thank you, Equinix, for being a sponsor. Sponsors ensure that the Packet Pushers can continue to offer high quality, deeply technical content for your professional development for free. That includes 14 technical podcasts on networking, security, IPv6, DevOps, and more. We've also got an industry blog, 2 weekly newsletters, a community Slack group, a YouTube channel, even an IRC group. You can find it all at packetpushers.net, all free with no login required. You can hear us on Spotify. You can thought lead with us on LinkedIn and rate us on Apple Podcasts. And last but not least, remember that too much networking would never be enough.